RHS pre-calculus presents linear and angular velocity, where we'll learn to find and use linear and angular velocity. To start with, look at this circle. The arc length will be represented by S, the radius will be represented with R, and the angle will be represented with theta. The basic equation is theta, which is equal to S divided by R, or arc length divided by the radius. This equation can be converted to S, which is equal to theta times R, or R, which is S divided by theta.
To recall, velocity is equal to distance over time. In this case, the distance will be represented by either the arc length or the angle.
The linear velocity is S over t, or arc length over time. This is how fast a point travels. The angular velocity is theta over t, or angle over time. This is how fast the angle is moving. Looking at these equations, we can combine them to show the relationship between linear and angular velocity.
As you can see, linear velocity is equal to S over t. Since S is equal to theta times R, this can be substituted into the equation for S. As you know, theta over t is equal to angular velocity. So, by substituting angular velocity in for theta over t, you get linear velocity equaling angular velocity times r.
To demonstrate all these concepts, we will now do an example problem. A lawn roller with a 10-inch radius makes 1.2 revolutions per second. We need to find A, the angular speed of the roller in radians per second, and B, the speed of the tractor that's pulling the roller, or the linear velocity. To solve this problem, you must know that 1 revolution equals 2 pi radians, so 1 revolution per second is 2 pi radians per second. For A, multiply 1.2 revolutions per second, the angular velocity, by 2 pi radians per revolution to convert the angular velocity into radians. This will make the unit revolutions cancel out, and we will be left with 2.4 pi radians per second. For B, we refer to the relationship between linear and angular velocity that we explained earlier, and use the equation linear velocity equals angular velocity times the radius. The radius is 10 inches, so 10 times the angular velocity we found earlier of 2.4 pi will be approximately 75.4 inches per second. We hope this helped you understand linear and angular velocity. Good luck.